Okay, so now we are recording the demonstration of this lab, experiment 11, conductivity of solution. So we already discussed the conductivity classified as electrolytes, non-electrolytes, and the weak electrolytes. So we will look at the different solutions here, and we'll see if they are in what category they fall. So you're going to look into the major species, and really the minor species ions. I personally do not know what to put in this, because many of them either they ionize or they don't ionize, or they weakly ionize. So pretty much we can just leave that column. We can write none in that, all of them. So anyways, let's look at first of all the deionized water. Now, the deionized water number 1, what do you guys think? Is it going to ionize or not? If it is ionizing, the bulb is going to light up. If it is not ionizing, the bulb is not going to light up. So or it's weakly ionizing, you will see a very dim light. So now, what do you guys make a prediction? Will it ionize or not? Deionized water. What do you guys think? None, because water just by itself will not ionize. So you see, when you put this thing in here, so you just put here on the table that it is a non-electrolyte, and then the major species is H2O molecules, this water, okay? Now the second one is the tap water. Now tap water can contain some minor like impurities or whatever they put to clean the tap water. It depends where, like for example, if you go, let's say Santa Cruz, or if you go to Pittsburgh, the tap water also has a taste to it. That means there are some ions. But let's see. So the tap water we have here, it's all clean. I mean, there's none. So it's none. So it's a non-electrolyte, and you are going to put the major species as H2O minor, right? H2O molecules, but there are like the minor species is none. Okay. Number 3 is NaCl. Now NaCl as a solid. Now if you have something as a solid, do you think it will ionize in a solid form? And will it conduct electricity? No. So in a solid form, sodium chloride, I'm like really touching the electrodes here, okay? You look at it here, nothing is happening. So in a solid form, sodium chloride, non-electrolyte, and it is non-electrolyte, and you are going to write down the major species is NaCl as a solid, and the minor species is none. Now comes the NaCl aqueous. Anytime you see the AQ, aqueous, that means it is soluble in water. That means now sodium chloride is dissolved in water, and yes, the same white sodium chloride, solid. Now the ions of sodium, oh, wait, 1 second. The ions of the solid, put this. The ions of the solid sodium chloride, sodium ions and the chloride ions are solvated. So fine, we don't see, but they are conducting electricity. So what do you see here on the board? The bulb is lighting out pretty brightly actually. So it's 100% ionization. So it is a strong electrolyte. Got it? Okay. Now, number 5. Number 5 is ethanol. It is ETOH. Now, what do you think? ETOH means C2H5. C2, there are 2 carbons, 5 hydrogens, and then OH group. So what do you think of this one? What do you think? Make a prediction. ETOH, will it ionize or not? Based on what I told you. Yes, why do you say yes? And why do you say no? I'm looking for a wash bottle. You don't even have a wash bottle. Or you can give me. Yeah, give me the wash bottle. Yeah. So some people said ETOH, in other words, C2H5OH. No, not the soap. I need the water. You guys don't have it in your drawers. Somebody said, yes, I need to, oh, there's one over here. Sorry, I have it. I got it. Okay. So some students said that C2H5 is going to ionize. So can I know why you're saying that? I mean, it doesn't matter. It's right or wrong, doesn't matter. I need to know what you're thinking. Some people said it doesn't matter, you know. You said that it is C2H5, which is going to ionize. Some people said it here. Come on. Some people said it here. I said no, but you said no. It won't ionize. Why? Huh? Alcohol, okay, but I did hear someone said yes. Yeah, why? Because of OH? Okay. Okay, I get it now. I get it. Okay, so that's very interesting. Yeah, it's very important I understand, you know, how the students are thinking. So here is a molecule, C2H5OH. And yeah, like NaOH is there. So you are thinking that C2H5OH will also release the OH ions, just like NaOH releases the OH ions. So that's a valid reason. So good, thank you. But there is a difference. Whenever the OH is connected to a metal, then only it is released as the OH ion. But when a OH is connected to a hydrogen and carbon like sites, then it is not released as OH. So make a note of it. Whenever there is lots of carbon hydrogen bonds and there is OH, that OH is not released, okay? But when OH is mixed with a metal, then it is released as ion. Got it? Make a note of it. So those are good points. Okay, now let's look at the C2H5OH. So C2H5OH, I just now cleaned it. And now I'm putting this here. See, because we need the ions, right, for the bulb to light up. So the bulb did not light up because the OH ions did not get released. Right here, you see that? Because OH ions are, so there is a covalent bonding in this molecule, C2H5OH. Okay, so that is the ETOH, the ethanol, ethyl alcohol also called. Okay, ethanol. Next is the same ethyl alcohol if you mix it in water. The same ethyl alcohol, you take this ethyl alcohol, C2H5OH, and dissolve in water. What do you guys think? Will it make ions? Yes. Okay. Okay, so one is the hydrogen bonds. Yes. So here is this ethanol. This is ethanol pure, like C2H5OH. And I just added some of it here, closing it back and putting it here. Now I'm going to add some water into it first. So let's put it here, let's show it like this. So here's the thing. 1 second. Okay. So here's the water I'm adding. And yes, the OH and the water molecule, they hydrogen bond. So you see a little bit of bubbling and all that little turbidity, but in the end, it's a nice clear solution because OH, C2H5OH, has an OH which hydrogen bonds with the water. Okay, so nice clear solution. Now, due to hydrogen bonding, C2H5OH dissolves, but the OH group is not released in the surrounding. The OH group is not released as the ion. The OH is not released as the ion. That is why, you know, it's not going, just a minute. Small while. Here. So this is a nice clear solution. This is a nice clear solution of C2H5OH with water, and you mix it and it forms a nice clear solution, but it does not conduct electricity because the OH is in hydrogen bonding with water, and OH is also covalently bonded to C2H5OH. It is not released as an ion. So therefore, we need ions for the electricity to be conducted, okay? All right, so that was one thing. Now, let's get the other one. Okay. So that was number 6. So number 6, non-conductor, non-electrolyte, okay? The major species is the full molecule of C2H5OH and water, and minor species is none. Next is the number 7, sucrose. Now, sucrose contains lots of OH groups. Sucrose contains lots and lots of OH, right? Sucrose is a sugar, right? And this sugar is, you know, white, solid, crystalline, as you can see. Now, solid obviously will not conduct electricity. So here I am putting sucrose there. Now remember that sucrose contains lots of carbons, lots of hydrogen. So it's a covalent molecule. And it contains OH groups, but the OH groups are also covalently bonded, not available for, you know, as ions. So, but they will, you know, form hydrogen bonding with water. So here you will write down non-electrolyte in a solid form, and the major species is a full molecule of C12H22O11. Next, when you take, this is number 8 now, 8. When you take a sucrose, that is a sugar, and mix it in water. Okay, now this contains, again, like I said, a lot of OH groups, but these OH groups are not available for bonding, for you know, conducting electricity. So sucrose is soluble in water. Lots of OH groups are here. Lots of OH groups dissolve in water. So that's why it's forming a nice clear solution, right? And this clear solution is because OH groups get hydrogen bonded with water. So that's how it dissolves. But the OH groups are not available for bonding. So non-electrolyte. And major species is still going to be C12H22O11. Okay, so that was number 8. Now we are looking at the next is number 9, which is 1 molar HCl. Now 1 molar HCl means hydrochloric acid, the molarity of hydrochloric acid, the strength, how strong. That's the concentration of hydrochloric acid. Pretty strong. You know, still hydrochloric acid is one of the strongest acids. So anyways, every time I'm doing it, I have to clean this. I don't have any residual, you know, and ideally I should be using a Chem wipe, but I don't see it here. Okay, just clean it up. Okay. All right, now we have HCl, hydrochloric acid. Nice clear solution, okay? And HCl, remember I told you 100% ionization. Now pay attention to the bulb. Look at that, how bright it is. 100% dissociation in water. So HCl as a gas is bubbled in water. That's how it gives HCl aqueous. And 100% hydrogen ions and 100% chloride ions. So it is a strong electrolyte. Now the major species are hydrogen ion. Actually there's a hydronium ion, but for now just write down. Hydrogen ion is the major species. Other major species is the Cl ion, okay? So both of them. And the minor species is none. I mean, pretty much water is a solvent. So I don't know what that means, but here, but it is still, like water will not ionize, not at all. It's only the hydrogen ion and the OH ions, okay? Hydrogen ions, the OH ions, and in this case, it's the chloride ions. Okay, next is the acetic acid. Now, acetic acid is vinegar, okay? Acetic acid is vinegar, and let me just wash this so we know. So remember, we talked about acetic acid. Now remember the glow of HCl versus the glow of acetic acid. Acetic acid is also going to release hydrogen ions. But look at this. So you see, it's very dim in comparison to HCl. So it's a weak electrolyte. Weak electrolyte, less dim. So here you will see the major species is C2H5O, where is it? Like C2H3O2H, the hydrogen is still intact. That is still the major species. The minor species are the ions. And the ions are, which one? C2H3O2, 1 negative charge, and small amount of hydrogen ions also. So these are the minor species. Got it? The minor species is hydrogen ions and C2H3O2, 1 minus. Okay, so that's the, both of them, all of this is going to be aqueous. The only thing is that it is very slow ionization or weak ionization. So not all of it is available, but you know, that's why you're showing in the bottom. Clear? All right, now we are looking at the NaOH. Now, this is the difference between the OH that we talked about. The OH that was present in C2H5OH versus the OH present in NaOH. I'll show you. Here is the NaOH. Okay, just give me 1 minute. I need to see where's the NaOH. Yeah, okay, yeah, I remember it was not there. Okay, hold on to this. Okay, they didn't give us the NaOH, but NaOH will also ionize, strong ionization in fact. Okay, let's look at next, ammonia. Number 13 is not available. Sorry, number 11 is not available. So you can just write down, it's a strong electrolyte. It will 100% ionize. The major species is going to be Na and OH. Na plus 1 charge, OH minus 1 charge. Okay, and then minor is none. Now let's look at ammonia. Ammonia is ammonia. When ammonia gets bubbled in water, right? When ammonia gets bubbled in water, it reacts with water molecules and it forms NH4 plus ion. So let us see. Here, very weak electrolyte, but it is still conducting electricity. So there is ammonium ion and OH ions here. Ammonium ions and the OH ion. Now let's see if I can get NaOH also. So hold on to this. So this completes. Now major species here is NH3 is still going to be the major species, but minor species are NH4 plus and OH minus. None, and the rest is just one none. Okay? I mean, any questions so far? Clear about the OH ions story?
What was the minor species?
Number 10. Minor species for, this is the, minor is the C2H3O2, 1 negative, and H plus positive. So those are minor. So small amount of ions are released. Same is the case with the ammonia also. Small amount of ammonium NH4 plus and OH minus. So those are minor for ammonia. Got it? Okay. Now the next is these reactions, conductivity before mixing, conductivity after mixing, and explanation. Okay. Now here in the questions, we already covered these reactions, the molecular, ionic, and the net ionic equation. We've already covered that in the lecture. But let's look at now when ammonia and acetic acid mix. Okay, what happens? So ammonia is actually ammonium hydroxide. It's ammonium ion plus OH ion because it's ammonia reacts with water. Okay, so here you have, I'm putting in, so some amount of ammonia in this. Okay, so let's just do this. That was a lot, but it's fine. Okay, so here is ammonia, and we have to mix it with the acetic acid. So, I mean, you should ideally use, if you really want to run the reactions, you should ideally do the calculations, how much of each you need and so forth. But since we are just demonstrating, now that's ammonia. Ammonia was a weak conductor before mixing, and acetic acid is also a weak conductor before mixing. So look at this again. Very weak electrolyte, ammonia. Acetic acid is again the vinegar. Okay, here we have very weak, right? Both of them are weak. Now mixing the acetic acid with ammonia, and it should give you ammonium acetate. 1 minute. Okay, so mixed it, ammonia and acetic acid mixed together, and they should give you a reaction. And look at that. What is that? Strong electrolyte. So 2 weak electrolytes make a strong electrolyte. You see that? What a glow of the bulb, very nice and clean. So that is, the molecule that is formed is actually ammonium acetate. Ammonium acetate. Now just give me 1 minute. Here we have the ammonia with acetic acid. Conductivity before mixing is weak conductivity or weak electrolytes. Conductivity after mixing is a strong electrolyte. So because ammonium ions, and acetate ions, they break up in the water, right? And so basically that's why they are able to conduct electricity like completely. All right, now we have, let me just put this here. Okay, the next is this table 2, table B, test of the household samples. Now here we are looking at the solubility in water, strong and weak electrolyte, major species and the minor species. Now we are looking at the baking soda. Okay, baking soda substance, solubility in water. Okay, so here's the baking soda. We've all seen it, right? Solid.
Are you skipping the second?
Pardon me? Oh, sorry. Yeah, sorry about that. I did skip. Sorry about that. Okay, let's look at the next one. Barium hydroxide and sulfuric acid. Okay, yeah. Barium hydroxide and sulfuric acid. All right. Here we have the sulfuric acid and barium hydroxide. So we talked about barium hydroxide. 1 minute. Acetone. Water. Oh, right here. Okay. Barium hydroxide. Okay, I want to show you how it looks like. You see that? So it is soluble in water, as we looked at like that. That's the exception. All the hydroxides are insoluble except sodium hydroxide, like the group 1A and the ammonium. But barium hydroxide will dissolve in water, but partially. So it's like some of it is soluble, but some of the white stuff you see is like still it's insoluble, okay? But let's see, will it conduct electricity or not? In other words, is it going to ionize into barium ion and the OH ions? So it's kind of like, it's still a nice, I wouldn't say like it's a very strong electrolyte, but it's not a weak electrolyte either. So it's kind of like in between. So you can still put this, like, you know, what you see here is strong electrolyte. So you guys can put it as a strong electrolyte. So yes, it is ionizing, giving you lots of barium ions and lots of hydroxide ions. Okay. Now comes the sulfuric acid, very strong acid. Be very careful with that. Okay. So here, washing this all the time, so there is no residual. Okay, here, all right, so it's like this. All right, now we have sodium and a sulfuric acid, H2SO4, okay? So sulfuric acid, very strong acid, very nice and clear solution. And the moment, oh my God, very, you know, because I'm very close to the filament here, I can see, you know, like it's how, like I can see the glow, the extent of the glow. So extremely strong acid. And so the stronger the acid, the stronger the electrolyte it is. So it's a strong electrolyte, sulfuric acid. Both of them are strong electrolytes. Now comes the reaction where you mix the sulfuric acid with barium hydroxide. So let's do that. Okay. So sulfuric acid and barium hydroxide. So I'm taking this barium hydroxide and I'm adding it to this piece, a little bit here. Okay, so it's kind of like still a clear solution. You see, it's still a clear solution, barium hydroxide. Okay, now turning it off and then bringing in sulfuric acid. All right, sulfuric acid and barium hydroxide. Here. Mix the two. What do you see? What is this now?
Cloudy.
Cloudy, yes. And why is it cloudy? What is formed? What is formed here? What is formed? Come on. Barium hydroxide reacting with sulfuric acid. We covered this in the lecture. Yes. Come on, guys, check your lecture notes. Tell me. Barium hydroxide and sulfuric acid, when they mix, right, you see the turbidity. And it is still like, you know, that's what I'm saying. In this reaction, we should have used the exact amount of HCl, H2SO4 that was needed, because there's still some residual sulfuric acid. There is still some residual barium hydroxide. However, the reaction has started and eventually you will see more and more barium sulfate forming, right? So barium sulfate, when all of the HCl, H2SO4 is consumed, when all of the barium hydroxide is used, then the reaction would be complete, right? One of the components has to be, has to be a limiting reactant. But anyways, the turbidity tells us this is barium sulfate. And this barium sulfate is insoluble in water. That's why it's, crushing out. But ideally, I shouldn't see, the glow. So you can write this down that conductivity before mixing is strong, but once all of it is, the reaction is complete, so the reaction is still occurring. So that's why you see the lighted bulb. But once the reaction is done, then it is not going to be a good conductor of electricity because barium sulfate does not dissolve in water. Okay. I'm going to just leave it here. Maybe, once it's done, then we can look at other things. Now, let's look at the next table, which is, the next table is the test of the household samples, the baking soda. Okay, solubility in water. Now, we take the baking soda and we see whether it's soluble in water or not. And then what happens when will it conduct electricity or not? So here's the baking soda, right? Obviously, when it is in a solid form, it won't conduct electricity. You mix it in water and then you'll see whether it will or not. So here I've added some baking soda to this this guy, the empty beaker. Close it and add water to it. And here I'm going to add DI water because you want absolutely clear water. So here's the DI water added to baking soda, and we'll see what happens. So okay, so here's the thing. Mix it like this. So it's dissolving. A little bit is left. Little bit is left. Keep on doing it. So remember that you're disturbing the electron clouds in water, or the molecular clouds. So here is. Majority of it is dissolved, a little bit is still left. So it's not like immediately it dissolves. You have to shake it. And if I heat it, it will dissolve. So most of it is gone. Okay. Now, so you can say that it is soluble in water. So solubility in water is soluble in water because anyways, it has sodium, right? Now let's look at the electrolytes. Now, bulb is lighting up. So it's a strong electrolyte, right? So sodium ion breaks up and the bicarbonate ion break up. So strong electrolyte. The major species are like the sodium ion, Na+, and the bicarbonate is HCO3 minus. HCO3 minus, that's the bicarbonate. Okay. Any questions so far? Any questions, guys? All good? Okay, let me just clean this. Next is the acetone. Now, acetone, what do you know? We covered all this in the lectures. Acetone, tell me, acetone. Acetone is CH3COCH3. What do you know about the CH containing compounds? Yes? Non-polar. Okay, the CH is a non-polar side, but will it ionize? CH is covalent bonding, so it will not ionize. Okay, and there is CO. CO is covalent, is also covalent bonding, but it is a covalent bonding, but it's like it's a polar side. Okay, but it's not going to ionize. The oxygen is going to remain intact. Okay. So here's the acetone. You guys, I don't know if you guys, like the nail polishes, if you want to remove nail polish, then they use acetone there. So I'm trying to bring acetone in this. So it's a nice clear solution. Like it's not even a solution, it is acetone. It's clean and clear, okay? Get some more. Okay, now, will it break up into ions? No, because it's an organic compound. CH3COCH3 is organic. It's not going to ionize. Hence, will not conduct electricity. Okay, so non-conductor of electricity. Okay, guys. All right, next is, oh, sorry, we had to do the solubility in water. It is soluble in water because acetone, where did it go? Let me just make it again. Acetone is right here. So here's water, and so this is water, and I'm adding acetone into it. It shows a little bit of milkiness, but it's not really, it's the hydrogen bonding happening. So because of hydrogen bonding, there's a little bit of, but it is still clean and clear. It is soluble in water. You see the light can pass through. It's a clear solution, okay? All right, guys. So that's the deal with acetone. Okay, so soluble in water, both of them due to hydrogen bonding. Acetone as well as, now next comes the isopropyl alcohol. Isopropyl alcohol contains 3 carbons, okay? Acetone also contains 3 carbons. The difference between acetone and isopropyl alcohol is that isopropyl alcohol contains OH group, but the OH group in these type of, all the organic compounds which contain carbon, lots of carbon, they have very weird names. Isopropyl alcohol, acetone, butanol, butane, formaldehyde, all these names, that's why organic chemistry, every molecule has that very specific name, okay? You just have to memorize that. Anyways, so let's look at isopropyl alcohol. That's the rubbing alcohol actually. Your rubbing alcohol, that's what it is. Okay, now isopropyl alcohol will also dissolve in water because OH, right? Hydrogen bonding. All right, so here is the water. Okay, so I have this pure and clean water, okay? And now I'm pouring some isopropyl alcohol in it. So as I'm pouring, yeah, it shows, of course, bubbling and all that, but, okay, but that settles down. That's the initial hydrogen bonding occurring, okay? And so now we have still, it's a clean solution. So soluble in water because of hydrogen bonding, but a non-conductor of electricity. The bulb is not lighting up, okay? All right, so that's one piece right here. Next is the major species are going to be full molecules. So they're not ionizing. So just write down isopropyl alcohol, the way the structure is given, acetone, the way the structure is given to you, okay? The major species in baking soda is Na and HCO3. So Na will have a positive charge and HCO3 will have a negative charge, okay? That's the major species. Now comes the minor species. I just put, there's no minor species in acetone, none, isopropyl, none. Now let's look at hydrogen peroxide. What do you think of hydrogen peroxide? Will it ionize? Will it ionize? Hydrogen peroxide? Okay, hydrogen peroxide, will it mix in water? Will it mix in water? So let me pour hydrogen peroxide. Here's the hydrogen peroxide. Okay. Nice clear solution, right? Nice clear. Now add water. Oh, so solubility in water, and then okay. So here dissolve it in water. So yeah, due to hydrogen bonding, it will dissolve. Nice clear solution. Put it in water. Put it in the in this system, and here. No, it's not conducting electricity. That means H2O2 does not break up into ions. Okay, H2O2, that's the hydrogen peroxide, will not break into ions. So the solubility is, yes, soluble in water, strong or weak electrolyte. It's a non-electrolyte. Major species is H2O2. Minor species is none. The last is tincture of iodine. Now, I don't know how the tincture of iodine is prepared, but it looks like this. And I'm sure iodine is, dissolved in something, but I do not know what is that something. It could be alcohol, it could be maybe ether, I don't know. But anyways, this is your iodine dissolved in something, and you use it like sometimes, these are used in doctor's offices and so forth. But anyway, so here is this tincture of iodine. What do you guys think of tincture of iodine? Will it be soluble in water? Will it conduct electricity? Let's see. Okay. Here, I'm adding some deionized water in this tube, in the beaker. So we have about 20 ml of water. Close. Here. Bring the tincture of iodine and mix it in water. Looks like this. Soluble. It's interesting because iodine is non-polar. That's what I'm saying. I don't know what it is mixed in or what's happening here, but it is soluble in water. And water is polar, the iodine is non-polar. So I think if iodine is in a solid form, then it won't dissolve in water, but it's something, I don't know what it is, but it is soluble in water, okay? All right, so that's one piece. Now let's see if it is going to conduct electricity. Whoa, right now it is conducting electricity also, look at that. So what I'm thinking is that it is breaking up into hydrogen ions and the iodide ions. Like iodine is reacting with water and it's producing hydrogen iodide. And hydrogen iodide is like hydroiodic acid. So it is HI acid. And HI acid will give you hydrogen ions and the iodide ions. So that's why they're conducting electricity. So this was in water. I just want to see the tincture of iodine. Oh, the tincture of iodine is even more bright. You see that? So tincture of iodine is, is something, which is containing lots of iodide ions. So that's the story with this guy. So you're going to write down here, soluble in water, yes. Strong electrolyte, just put it in strong electrolyte, it was. Major species as hydrogen ions and iodide ions. And minor species, none. All right. So that finishes the demonstration. And if you guys have any questions right now, you ask me, and I'm going to just stop the recording.